Good morning. Today I wanted to make this kind of unplanned video just to give an overview of the conics that we've looked at so far. And before I get into the specific review, it's also a good time to maybe touch base because after this week, after today, we have basically 2 more weeks of this course and then there'll be a final exam posted and so on. And in those 2 weeks, if you look at the calendar, the plan is that Monday, I will post a quiz over these first 3 conics, the circle, the ellipse, and the parabola. We will then take a look at the 4th conic, the hyperbola, and then we'll look at all the conics from a little bit different perspective using what's known as parametric equations. Ultimately, you'll get your homework component, a nice worksheet over everything we've done lately, and then our final test. So that's really what's coming the next 2 weeks. So as usual, stay on top of things. Make sure you contact me with questions. And let's get started. Right, so our 3 conics. I can't stress enough that we want to understand the conics geometrically through the plane slicing a cone. We also want to understand the conics in terms of a locus definition, which starts with the phrase a set of points and describes the requirements of those points. But we also need to, of course, understand the conics in terms of their equations. Now, when we have their equations, we should know all of their characteristics. And then from their characteristics, or the stuff, we can then get the graphs. So we're going to continually be working through those 3 things. We've got the equation, we've got what I call the stuff, or all of its characteristics, and we've got the graph. We've done this with pretty much all the functions we've studied this year, and we have to understand the interplay between these 3. So, first, circle's the most basic. Of course, we have the 2 big parts of a circle are going to be the center and the radius. That pretty much determines any circle. With the parabola, it looks like we've made it more complicated based on our normal ax squared plus bx plus c equals 0, or more quadratic form. The reason being is in this format, we know a lot more about the graph. And the big key, of course, is this p. We also know that it's the one that only one of the x or y terms are squared. If the y term is squared, this is going to be a sideways parabola, either to the left or to the right. If it's x squared, it's going to be upward or downward. What's going to determine that is the value of p, whether it's positive or negative. Some of the important parts here is we have, of course, the vertex of a parabola. We do have, which we could call the focus. We have a line, which is a directrix. Remembering that is a line. We also have this thing called the latus rectum, which is kind of that distance through the focus that hits the 2, it's perpendicular to the axis of symmetry, and it's going to hit the parabola at 2 points. So, anyway, that's the parabola. The ellipse, we know what an ellipse looks like. It's kind of a very general form of a circle, but what we have are 2 axes instead of just 1. Here we can think of the major and minor axis both being the same, R. Here it's A and B. And these A and B's can be switched. A is always bigger than B because it's half the length of the major axis. So if the larger number is under the Y, it's going to be kind of a vertical ellipse. If it's under the A or under the X, it's going to be a horizontal ellipse. This mysterious value C isn't really on the ellipse, but it does help us find what we call the focus. So here, again, we have vertices. There's more than one. We have foci. And then from that, of course, we still have a center. We have the major axis and the minor axis. Okay, so let's take a look at some examples. Here's an example where we're given this function, this equation. We want to identify it and graph it. Well, identifying it's rather interesting. Here, the only term that's squared is y. So it's going to definitely fall into the category of parabola. If it had an x and a y squared, it really comes down to the coefficients of those 2 terms. If the coefficients of the x and y squared are the same, it's going to be a circle. If the x and y squared coefficients are both positive, but they're not the same number, it's going to be an ellipse. And we've looked at examples of that already. But here's another one. So it's not quite in the form I like. So what I'm going to do is try to transform it into this form right here. And in doing that, I've got to complete the square. So I take these first two terms and ask myself, what would I need right here in order for this to be a perfect square? Well, what we need in that position is going to be half of this coefficient, add it, and square it, or square it, then add it. Half of it's -1, square it is 1, add it. We also have to add the 1 on this side. So I created a perfect square. So this becomes y minus 1 squared. Here we just get 8x. So we pretty much have all the information we need. If I now want to graph this thing, one thing I know is that the center is going to be 0, 1. How about the vertex? There's no center of a parabola. Sorry about that. So we get that because there's nothing really associated with this x, comparing it to that. Now, the other part of understanding the graph is this idea of p. P in this case is going to be 2. Because again, that coefficient represents 4p. So p equals 2. How does that really play out? Well, because it's a y squared equation, we know it's either open up to the left or the right. If it's positive, it's going to open up to the right. So if this is going to be the vertex, we know it's going to open up this way. So if I had to find some of the other types of things, for example, the focus is going to be 2 units over. So there's my vertex, there's my focus. If I did want to find the directrix, it would be this line here. Now, as far as graphing it, I could find more points. In other words, I could find kind of these 2 points, and we get a nice feel for what this parabola might look like. There we go. Now, there's one other thing about this. Since this is 2, okay, this is also going to be 2, because that's 2. This is also 2, because that's 2. So each of these are going to be 2 units. So what we have basically are these 2 points that we can identify. And that's really the lattice rectum. We haven't talked a lot about that one, but that's what it is. That's P, and that's P. So there we have the graph. If we were asked to list the focus, we could do it. We could list the equation of the directrix, which I'll let you go ahead and fill the gap in on that one. Now this final example is one that you have a few of these problems, especially on the ellipse section. And it's a lot of times has to do with maybe buildings or bridges where they're kind of semi-ellipses, which is a half an ellipse. Sometimes it could be parabolas or even hyperbolas, but for now we'll stay with the semi-ellipse. And here's one that's a pretty basic situation. We have some type of an arch, and it is a 100-foot span. Okay? And it's a semi-ellipse. And then what we are asked to do is we are told that its focus is 25 feet from that center span. So let's just say if that's 100 feet, we know this is 50, so here's the focus. Now if I wanted to, I could superimpose an XY axis on here, which is not a bad idea. So we know that this is 50, this is 25, so this point is 25 comma something, I don't know, and I don't care right now. But the big question is, how high is the bridge? In other words, what is the optimum or the highest it's going to be. So right here. Well, if we put all of this together, what have I really been given? One thing I've been given is that since this span is 100, as far as the equation goes, A is 50. The focus is supposedly 25 feet from that center, so that tells me C. And if this is what we're supposed to find, we know that that can be represented in the equation as B. So now I can just simply write that B squared equals A squared minus C squared. And B is approximately 43.3. Calculator would help you out with that. And that's using this relationship down here between A, B, and C. So we really don't have to write a full equation. Now I could go a step further. I could say, how tall is this underpass, or whatever you want to call it, at the focus? Well, now that I have B, I could actually write the equation, which would be x squared, because again, I can just consider that the origin, over B squared, which is going to be 50 squared, plus y squared over B squared, which is about this, equals 1. So that would be the equation of this parabola. So now, if I put 25 in for the x value, I can go back and find y. So that would give me the height. So once we have the equation, we can do a variety of things. But many times, we don't even need the equation. It's just this relationship between A, B, and C that we're testing. Okay, so I know that's a very quick recap. Hopefully it kind of puts you in a good mindset for these 3 conics. As I said, on Monday, first thing, I will post a quiz over these conics, and then the next day, we'll start taking a look at the hyperbola. So from now till then, your job is to continue making progress on 2.3 was the problem set involving circles, 11.2 for the parabola, and 11.3 for the ellipse. Throughout the weekend or today or even Monday, if you have questions on anything, send a quick email. I'll try to address it through the email, or if needed, I can type something up and send it out as a document for both of you. But other than that, enjoy the weekend, keep making progress, and we're almost there.